Hello everyone, welcome back again to Excellent Solutions, a guide to score 300 plus in Jamb. Today we are going to be discussing physics and the topic is thermal expansivity. So we are continuing from question 11 to question 20 here. And our question 11 says, a bar of initial length L0 is heated through a temperature change delta theta to a new length L. The linear expansivity alpha of the bar is, so if you recall the definition of linear expansivity, we said alpha equals to increase in length over original length times temperature change. So this one we now have alpha is now equals to increase in length is equal to L2, which is the L minus initial length L0 over initial length L0, then delta theta, which is the change in temperature. And if you look at our option, in option B we have L minus L0 over L0 delta theta. The answer is option B. The next question is question 12, and this question says a rod of length 10 centimeters. So we have our L equals to 10 centimeter or L0 is heated through 100 degrees Celsius. So it's heated through, not from. So this one, the delta theta is given, not theta 2 minus theta 1. So delta theta is equals to 100 degrees Celsius. And its final length is 10.26 centimeters. So our L2 is the same as 10.26 centimeters. What is the coefficient of linear expansivity of the rod? The question asks us to find alpha, which we know alpha is equal to L2 minus L1 over L1 delta theta. So this is now the same as our L2. We have 10.26 minus our L1. This is L1, which is 10, over our L1, which is 10, multiplied by our delta theta, which is 100 degrees Celsius. So this now gives us alpha equals to 10.26 minus 10, we have 0.26, divided by our alpha L1 is 10 times 100, we have 1000. So dividing this by 1000, we take our point backward 3 times. This is the same as saying 0.26 times 10 raised power of minus 3. So if we now take this one back, we have alpha equal to, take this one backward 3 times, 1, 2, 3. So we now have 0.12326 per degree Celsius. So if we look at our options, in option B we have 0.0026 per degree Celsius. The next question is question 13. This question says a metal rod 800 millimeters. So we have our L equals to 800 millimeters. Is heated from 10 degrees Celsius to 95. So theta 1 equals to 10 degrees Celsius and theta 2 equals to 95 degrees Celsius. If it expands by 1.36 millimeters, so our expansion, E expansion is the same as L2 minus L1, and this is the same as 1.36 millimeters. The linear expansivity of the metal rod is, so we are asked to find alpha. Remember we said linear expansivity alpha is equals to L2 minus L1, which is the same as expansion. Or let's say L2 minus L1 over L1 delta theta, which is the same as expansion over original length times delta theta. So we now have our alpha now equals our expansion 1.36. This we don't need to turn it into meters because this one is in millimeter, this one is also in millimeter, they will cancel. So divided by 800 open bracket, our theta 2, we have 95 minus our theta 1, which is 10. So this now gives us 1.36 divided by 800 times 85. 95 minus 10, we have 85. So this is now the same as 1.36 divided by 68000. And if we divide this, alpha equals to 0.00002 per Kelvin. And if we look at our options, we have it in option D, we have 0.002 per Kelvin. The next question is question 14, and this question says a wire of length 100 meters at 30 degrees Celsius. So we have our L1 is equal to 100 meters at theta 1 equals to 30 degrees Celsius. Has a linear expansivity of 2 exponential 5 negative 5. So we have alpha equals to 2.0 times 10 raised power of minus 5 per Kelvin. Calculate the length of the wire at minus 10 degrees Celsius. So we are now calculating, if this is the case, this is our theta 2. We are now looking for L1 at, this is now our theta 2, and we have our theta 1 is equals to minus 10 degrees Celsius. So if we look at this here, we say alpha equals to L2 minus L1 over L1 delta theta. So when we cross multiply here, we now have L2 minus L1 equals to alpha L1 delta theta. If we take this one and cross it to this side, it becomes positive. We now have L2 equals to L1 plus alpha L1 delta theta. So we have L1 here, we have L1 here, we make it common. We now have L2 equals to L1 open bracket 1 plus alpha delta theta. So if we now divide both sides by 1 plus alpha delta theta, we are going to have 1 plus alpha delta theta, 1 plus alpha delta theta. This one now cancels. We are now left with L1 equals to L2 over 1 plus alpha delta theta. So this now becomes L1 equals to, our L2 is 100 divided by our L1, we have 1 plus our alpha is 2 exponential minus 5, which is the same as 0.00002. Then multiply by our delta theta, which is 10, our theta 2 30 minus our theta 1 minus 10. So we now have this L1 to be equals to 100 over 1 plus 0.00002 times 40. So we now have L1 equals to 100 upon 1 plus 0.0008, and this is now 100 upon 1.008. If we divide 100 by 1.008, we have L2 equals to 99.92 meters. And if we check into our if we check at our options, we have option D, 99.92 meters. The answer is option D. The next question is question 15, and this question says a metal rod has a length of 100 centimeters. So L1 equals to 100 centimeters at theta at 200 degrees Celsius. So theta 1 equals to 200 degrees Celsius. At what temperature will its length be 99.4? So L2 equals to 99.4 centimeters. We are looking for what temperature, which is theta 2. So if the linear expansivity of the material is 2 exponential minus 5, alpha equals to 2 exponential minus 5 per Kelvin. So first thing we need to look here, we know that alpha equals to L2 minus L1 over L1 delta theta. So if you make L1 delta theta the subject, we are going to have delta theta equals to L2 minus L1. We just take delta theta and bring it here and bring alpha to its place. We have over L1 alpha. So this will now give us our theta L2. L2 is 99.4. 99.4 minus L1, 100 divided by our L1, 100 times our delta theta. We now have our, times alpha, which is 2 exponential minus 5. So we can now have delta theta to be equals to 99.4 minus 100, we have minus 0.6 divided by 100 times 2 exponential 5 is the same as 2 times 10 raised power of this is, we now take this power 1, 2, and we reduce this by 2, so minus 3. And this is now the same as having minus 6 over 2. You can now say times 10 raised power of, we now have this as minus 1. If this one goes up, then plus 3. So this is the 6 over 2. We now have 3. We now have delta theta equals to minus 3 times 10 raised power of 2, which is the same as minus 300. Bring this here. So if you have delta theta to be equals to minus 300, we call that delta theta equals to theta 2 minus theta 1. So minus 300 is equal to our theta 2. We now have theta 2 minus this is our theta 1, which is 200. Okay, we have minus 200. So if this one comes here, we now have theta 2 equals to minus 300. If this one crosses, it becomes plus 200. So we have theta 2 equals to minus 100 degrees Celsius. And if you look at our options, we have it in option D, we have minus 100 degrees Celsius. The answer is B.